Hey guys, just thought I'd show you how to put small bearings into gearboxes. I bought this Retro Arms brand gearbox for my Tokyo Mari P90 airsoft rifle, and it's a very nice piece of kit. It's billet aluminium machined and it's CNC and it's got some really nice design features. But, and this isn't a bad thing, but the bearings are very hard to put in by hand. The tolerance is about 0.01 millimeter. So it's very tight and you literally can't put it in by hand. So I looked on YouTube to see if there was any special trick, and I found the Retro Arms guide on how to put the bearings in. And for me, for my likes, it's a little bit barbaric how they showed. Basically what they did was they put the bearing in, they gave it a whack with a hammer, and then they got what looked like to be some of the tooling from their CNC mill, which is a piece, a cutting bit about that big, and they set it on there and then went whack and knocked it in. That's no good for a bearing, because you don't want to shock load the bearing, and if you were to inadvertently hit the inner race, it's the force, that shock load is going to go through the balls to the outer race, because that's where the friction is, where it's going into the hole, and those balls are going to dent the races because it's just a point load. There's about 8 balls or so in there, and you got, well, in total 16 points, 8 paths for the force to go through, and you're going to dent your race. When that happens, your bearing goes notchy as but the balls bounce over those dents, and you may as well throw the bearing away. So I didn't really want to give these things a hit because they're ceramic bearings, and to get them posted here to Japan, it cost me about $30 in total for the whole purchase, and I don't want to pay that again. So I thought, how can I do this without damaging the bearings or risking damaging the bearings? And the way that we put the bearings in is we press them in. That's how they're always put in. You never see a manufacturing process where people whack them in like that. So we don't want to buy a press or buy special machinery, but I figured out a very easy way to do this, and it will cost practically nothing. If you got some nuts and bolts and screws and washers, you can probably rig this up for free. Otherwise it'll cost you a few dollars for a few screws. So basically what we want an M3 screw in this case, because the inner race is M3, the hole through the middle there. So we've got ourselves an M3 screw, a couple washers, and a nut. That's pretty much it. There is one extra thing that we need, and that's a spacer. I'm using this washer, which is for using countersunk screws on a flat surface, kind of like a decorative item or something. Simply because on this gearbox, the thickness of the aluminium is thinner than the width of the bearing, so the bearings sit proud of the surface. So if I was to use a washer on that surface, I can't pull the bearing all the way through. So I need to put a spacer so the bearing can pull into the spacer and fully seat on the other side. That's all that's for. But we're going to use that second. So first thing is we need to get our screw and our 2 washers. I use 2 washers so they don't flex, because if they're going to flex, they're going to pull downwards and they're going to put that force on the inner race. By using 2, it's a lot stronger and it is a flat surface across the bearing. Stick that through our bearing, and then we put a washer on the other side. This, by keeping it nice and short like this, it'll make sure the bearing goes through straight. Then we stick our screw on the other side, screw that up, and this thread, I've already used it, so it's a little bit wonky, but it'll be alright. There we go. So we've got our rig set up, spanner or a socket or whatever you've got for the nut, and as I'm an electrician, I'll be using a 1000 volt rated screwdriver just so I don't electrocute myself, and then we slowly tighten it up. Now make sure that you don't go crazy and cause a thing to go in sideways or on an angle. Using it like this with a washer flat, it'll keep this straight, so it shouldn't be too much of a problem. Once you feel it go tight and it's, you know, it's not going sideways, that means the bearing's pretty much in. So in this case, I want to loosen that off because the bearing isn't actually all the way through because of that problem where they sit flush. Proud, rather. So we'll take that off and I'll show you what I mean. So you can see there, oh, is it going to focus? Focus. So this one here is just sticking up and this one's flush. That's the one I just did now. But on the other side, it's going to be hard, but these are sitting lower than this one, simply because I couldn't pull that through because the washer was in the way. So one more step, we'll put our spacer on. Now it's going to be easy to do this second because this has got a bit of play in it, just because it's the one I could find that would give me enough room underneath. And if I did put this on to start with, it's very hard to make that straight. So once it's in the hole already, it can't move sideways. It's going to go straight for the rest of the way. So we'll put a big washer on, just so it covers the whole surface there, and then we can continue pulling it through. Then we get our handy dandy spanner and we pull it in. When the bearing goes in correctly and it's not skewed sideways, it's not sitting at an angle, you'll feel it. You'll feel it, the resistance as it's sliding in, but it will feel smooth. If it suddenly binds up, back off and check it, because you don't want to cause a problem with your gearbox, especially an expensive thing like this. You don't want to gouge out the hole or cause it to go oval or damage your bearing. And that is the bearing installed. Easy, no stress, no damage, no banging the thing with the hammers. Beautiful. Hope that helps you. See you next time.